This is one eyeball. This is the right side. I'll take it. And this is one another eyeball what I'm having. This side I'll take it as a left side. We have a lens and we have a lens on this both sides. This lens, you need to be aware that this lens what you are having it, this lens is convex. Okay, it is a convex lens what you are having. Why is it important convex? Because it is like this. The radiations which are coming gets reflected and falls like this. Along with it, the image also gets inverted. For example, the image what you're seeing of a human being standing in this manner, it gets inverted. So it will be in this manner what you will be having here image. For that reason, it is important. It gets inverted. So two things happens. The rays which are coming from this side will get reflected this side and this side. So it goes reflected opposite side. So on the retina, what it falls, it's the opposite side of the rays of the light which are coming have fallen down. Okay. So in between what we have is the nose. So here what we are having is the nose. That's why it is known as nasal part. This is also known as nasal part. Here what we have is the temple. So we have an temple region or temporal retina or temple region, what you call it. Temple, I'll just simply write it. And here also what you are having is the temple what you are having. So we know the temple what you are having here. So what happens here? So rays what is coming from the temple region falls on the nasal side. So nasal side near the nose, it falls on the retina. Same thing happens on the opposite side also. The rays which is coming from the temple side falls over the nasal side. And this is carried by the optic nerve. And this optic nerve crosses to the other side, other hemisphere it crosses. Same thing happens. It is carried by the optic nerve and crosses to the other side. Optic nerve exists from where? From the orbit, from where it exists. It exists from the optic canal. Okay, that is important anatomically. It exists from the optic canal. What happens if the rays are coming from the nasal side? What we'll be seeing? From the nasal side, what you are having, it falls over the temporal region of your retina. The rays which are coming from your nasal side falls over the temporal region of your retina. And this is, again, this is nothing but part of the optic nerve itself. It exists from the optic canal and it doesn't cross. It goes in the same hemisphere itself. Here also, it doesn't cross. It goes in the same hemisphere itself. All right. So let us discuss the lesions at this level itself with this much knowledge what we are having. Then we will continue how the optic tract goes in. First, we'll start each one of these lesions. We will be going through each one of these lesions. So we have a lesion here at the level of what? Optic nerve. So optic nerve, we have the lesions. So I'll draw two eyes. This is the right side eye. This is the left side eye. Because it is a complete, both the rays which are coming from this side and this side are getting involved here. Completely loss of vision will be there in that particular eye. So this is the right side. That's why the right side complete loss of vision is there. Left side, nothing, no loss of vision. Completely fine lesion what is having. This is nothing but optic nerve what you're having. Next lesion we'll be seeing is at this level. This level is known as optic chiasma. Optic chiasma, it is important. It is very much tested in the examination. Why is it important here, optic chiasma? Right above this is the pituitary gland what is present here. Any enlargement of the pituitary gland can cause compression of the optic chiasma and resulting in the vision loss. So optic chiasma is involved two eyes. Again, I am drawing it. What will happen here? Here the radiations are coming from the temporal side here coming. From the temporal side, it is coming here. Then it is coming here. It is also coming from the temporal side. So the vision will be lost by temporally. So temporal side, loss of vision. Temporal side, loss of vision. Bitemporal loss of vision is there. Along with bitemporal loss of vision, it is heteronymous, we call it. Okay. It is known as bitemporal heteronymous. Why do I call it as an heteronymous? Heteronymous, what we call it. Why do I call it as an heteronymous? It is not in the same side. It is both are opposite to each other. For that reason, it is known as heteronymous hemianopsia. Hemi means half of the vision is gone. Half of the vision is gone in each of the eye. So bitemporal heteronymous hemianopsia, it is known as. This area, what we is known as is optic tract. Till here is the optic chiasma. Here is optic tract. From here below where we are going, it is always contralateral loss of vision will be there. So optic tract, what happens in the optic tract will be drawing here. So let us break down what happens in the optic tract. So optic tract, what you are having, one is coming from the left side you're coming from this region, you're getting it, that is nothing but from the temporal region it is coming. So left side, temporal region is lost. So temporal region is lost. On the right side, what happens? On the right side, what you're having, this is the nasal, and nasal. So the nasal region will be lost. So both are on the same side, what you're having. And it is lost, one on the nasal side, another one on the temporal side, opposite. This is known as contralateral homonymous hemianopsia. So contralateral because it is on the opposite side, contralateral because right side is involved, but you can see the lesion here is on the left side. Same thing on the left side, what you are having. That's why naming wise, they are named it as a contralateral, opposite side, contralateral homonymous hemianopsia. Same thing, hemianopsia. Homonymous hemianopsia. Homonymous is not heteronymous, it is homonymous what we are having here.